right, well, welcome back. I hope you're comfy and settled in and ready for a snack, because in today's lesson we're going to talk about one of humankind's greatest inventions, which is the grilled cheese sandwich in all of its gloriousness. I'm going to use the grilled cheese sandwich as a metaphor, literally at first, but it's more of a metaphor for how to deal with a particular type of stoichiometry problem. So I'll review what stoichiometry is here first, and then we're going to kind of move on to this next piece about what happens when we do these sorts of chemical reactions if we know the quantities of both reactants and something runs out. So that's kind of the goal of today's lesson. So number one, just to kind of review, with our regular stoichiometry problems, keep in mind the central idea of any stoichiometry problem is to be able to use the balanced chemical equation as a recipe. And the center part of that is the mole-to-mole ratio. Those are the coefficients from the balanced equation, and that tells us how many moles of each reactant or each product go into or come out of a balanced chemical equation. So whenever we want to make any predictions about how much reactants we need, how many products we're going to get, whatever it is, we always have to use that mole-to-mole ratio, the coefficients from the balanced chemical equation. So that's point number one from our previous lesson. Number two, when we start moving on with these things, it's simply a way to use dimensional analysis to be able to attack these sorts of problems. When we're converting from moles to moles, the idea of kind of crossing down and using that mole-to-mole ratio helps us to make sure that we're doing our math sort of right side up, that we're multiplying when we should multiply and not dividing when we should divide. Furthermore, as we move forward into the next series of these, we need to keep in mind that dealing with moles is the key idea, but moles aren't necessarily the most useful in terms of lab calculations. So if I asked you to go out and measure 2.4 moles of salt or something along those lines, you wouldn't know what to do. When we deal with numbers in a lab situation, we're always using grams. So building on top of that central mole-to-mole ratio is usually molar mass steps, either molar mass converting to moles, or at the end, molar mass converting from moles to grams, just depending on what we want to do. So those are kind of the two big ideas. Number one, you always have to have a mole-to-mole step. And number two, a lot of times we have that molar mass step in there to either convert from grams to moles or to convert from moles to grams, just depending on what we want to accomplish. So more realistically, what happens when we're doing chemistry for real? And in the problems that we've done before, we've either assumed that the reactants were going to be present in exactly the right amount, or I only gave you the amount of one reactant. We just sort of assumed that the other reactant was there. So this is where we start talking about grilled cheese sandwiches. What happens if your ratios, the amount of reactants and products that you have, the ratios are fine, but maybe the amount that you have on hand isn't exactly right? And if you've ever cooked before or tried to make sandwiches, something like that, you know that sometimes you run out. In fact, you always run out of something. And how do we deal with that mathematically when we're running out of a reactant or we have too much of a reactant? So let's take a look at our grilled cheese sandwich here. So I'm going to go with a Wisconsin-style grilled cheese sandwich, which has 3 slices of cheese along with 2 slices of bread. I know 1 piece of cheese just is not enough. That's just lame. So got to have 3 slices of cheese. And we're going to make one B2C3. There is my formula for my grilled cheese sandwich. And this is the equation we're going to use to kind of talk about our simple kind of mental picture of what happens when we have reactants that run out. So here's an example. And this is, I know, a lot to look at, so kind of follow along with me here first. So number one, let's say you have 8 pieces of bread and 8 pieces of cheese or slices of cheese. How many total sandwiches can you make? And it has to be a complete sandwich. You're not allowed to make a half sandwich. You're not allowed to make an inadequate sandwich, maybe that only has 1 piece of cheese on it. How many truly complete sandwiches can you make? So here's kind of a basic stoichiometry problem, mole-to-mole ratio kind of. Here's the big strategy. It's in yellow here in the middle of the screen. When you're given the amounts of 2 reactants, I'm given the amounts of bread and the amounts of cheese, treat it like 2 separate problems. Don't try to do it in one single problem, but do it as 2 separate problems. So in this one, I'm going to do one little wonder fraction here where I'm converting from bread to sandwiches. Okay, just considering the bread, how many sandwiches could I make? Well, if you take a look, it's pretty obvious to do the math on there. 2 pieces of bread per sandwich, that gives me 4 sandwiches that I can make. All right, part 2 of my strategy now is let's just look at the cheese. Let's forget about the bread. and just look at the cheese, just considering that, how many sandwiches could I make? Well, if I'm starting off with 8 slices of cheese, and it's 3 slices of cheese makes 1 sandwich, because that's my mole to mole ratio here, then I could make 2.7 B2C3s, 2.7 sandwiches. So really I can only make 2 sandwiches. That 0.7 is an incomplete sandwich and just not acceptable. You'd have to give that one to the dog. It's just not okay. So when we take a look at these, again, what's different here is that now I know quantities of 2 different reactants. I'm given 2 numbers at the beginning. All the other ones we've done so far, you've only been given 1 thing. Here I'm given 2 things. I'm given the amount of bread and the amount of cheese. And the strategy is to deal with each one separately. Well, how many sandwiches could I make with this much bread? How many sandwiches could I make with this much cheese? And again, now I know kind of what's going on. I have 2 numbers here. What do I do with these 2 numbers? Okay, when you have 2 answers like this is the next step. They weren't exactly the right amounts for each other. I had some leftovers, right? Enough bread to make 4 sandwiches, but only enough bread to make, or only enough cheese to make basically 2 sandwiches. So what does this mean? It means that my cheese actually ran out, right? I could only really make 2 complete sandwiches. Those 4 sandwiches that the bread said, some of those sandwiches are really going to only be bread. That's all that you're going to completely run out of cheese. It'll just be like a slice of bread and another slice of bread. Definitely not a grilled cheese. So we would call the ingredient that runs out first, in this case it's the cheese, the limiting reactant. I didn't have enough cheese to make all of those sandwiches. It limited the number of sandwiches that I could make. The bread, on the other hand, is the stuff I have leftovers from. It kind of gave me this imaginary, like, oh man, it'd be great if I could make 4 sandwiches, but I really can't. That's what we call an excess reactant. There's extra of it, so there's going to be some leftovers, bread that's not used, at the end of our problem. And the way I could tell was by looking at those numbers of sandwiches. The one that had the least number of sandwiches, the 2.7, or actually 2 in this case, is the limited amount of product. So it's got to have the limited reactant. The one that's too big, that's just fantasy land there. Man, 4 sandwiches. Aren't you hungry? Okay. So how do you do this? Here's the general rules. This is a good one to take notes on if you're thinking about it. How do we identify which is which? The limiting reactant, by definition, is the one that runs out first. How can you tell? By using a math problem. You can't tell by the original numbers. You have to do the little Stoich problems, the little Wunderfractions. And the one that has the lowest amount of product is the one that has the limited reactant. Remember, a product is on the right and a reactant is on the left. So if we had 2 sandwiches for one and then 4 sandwiches for the other, the reactant that made only 2 sandwiches, that's our limiting reactant. The excess reactant, on the other hand, is the one that's not used up. We have leftovers at the end of this reaction. And these give us a kind of a fantasy number. It's a bigger answer between the 2 of them. And that's kind of a predicted amount of product, but it's not possible to get there because we're going to run out of cheese in this case. So the amount of product, there's this key idea down here at the bottom. The amount of product, the actual amount, is always determined by the limiting reactant. The excess reactant, there's just too much there. And again, those last couple sandwiches just are not actually done. So you always have to look at that lesser value. The limited amount of product and the limited reactant are the ones that are really the key values for us. All right, so now I think we have to start doing some problems that kind of go along with this. So again, the strategies. Consider each one separately. If you're given the amounts of 2 different reactants, you do one to the product and do the other one to the product. And again, you're trying to do it at first, you're just sort of feeling it out. Well, all right, how many sandwiches could I make from this? How many sandwiches could I make from this? Then you have to make a decision, and that's the important part here. The math itself isn't enough. You have to choose the smallest or the limited amount of product is the right answer, and we call that the theoretical yield. So now you have a third kind of vocabulary word. We have limited reactant, excess reactant, and theoretical yield. The theoretical yield is that limited amount of product, the smaller answer, and then that's our sort of correct answer. The other one is the excess reactant. All right, so I'll give you a break from the grilled cheese sandwiches. Are you drooling? Man, that grilled mac and cheese, oh, so good. So, non-cheese example, we're going to do some chemistry here. So you can always tell this kind of problem, again, because masses of both reactants are given. So here's what we've got. Here's our problem that we're going to use here. Sorry, get out your pencil and paper and calculator and all that stuff. So let's assume, or let's imagine that we're combining 2.5 grams of salt, sodium chloride, and 5 grams of silver nitrate in some water. So we've got 2 different solutions. And then how much silver chloride precipitate could be produced. So what we basically have right here is, this is one of the 2 solutions down here. It's probably the silver nitrate. And then this one up here is probably our sodium chloride. And so where they come together, they're making that precipitation reaction. So we're going to figure out how much of our product could be actually produced from this. So how many sandwiches can we make, right? So we've got 2.5 grams of bread and 5.0 grams of cheese. right? Those are our two different reactants. Again, you can always tell this kind of problem because you know the amounts of two reactants. You're given two numbers in the problem here. Both reactants are known. So, first thing first, you have to write the balanced equation. Here it is. And then the second thing is we need to check to make sure that it's balanced, and it is balanced because everything's a +1 or -1 charge, so that makes our lives a little bit easier. And then I'm going to start kind of figuring out what our key ratios are. And this is a process I suggest that you do. I go and label the equation. I've got 2.5 grams of this and 5.0 grams of that. And again, I know it's a limiting reactants problem because I've got two different things labeled on the left side. And I'm trying to figure out silver chloride, which is this want to, it's our sandwich over here, on the right side. So again, these are kind of classic hallmarks of a limiting reactants problem. So strategy, you're going to do two Stoich problems, one for each reactant, and you have to go to the same product. So I'm going to do one problem where I convert from NaCl to AgCl, and then I'm going to do a second problem, this is our cheese problem, right, from silver nitrate to AgCl. Kind of like I did before, one went from bread to sandwiches and one went from cheese to sandwiches. Same idea, two separate problems, and then we're going to evaluate our choices based on those. So here's what it looks like. You're going to start doing the math. All right, so here's my first Stoich problem. Here is I'm converting from NaCl. This first step right here, you should recognize it, I hope. That's a molar mass step because I've got grams and moles, so I should have gotten those masses directly from the periodic table. Sodium's like a 23 and chlorine's a 35, roughly, and then you add them together to get 58.44. Then this step right here is our mole to mole step. And then I can kind of think about doing our math part of this, multiply across the top and divide by the bottom. In this case, when I do the math on here, it tells me 0.043 moles of AgCl. So the next step is to do problem number 2. So this was like our bread to sandwich problem, and now we need to do the cheese to sandwich problem. Again, same product is what we're going to go to. So here's what it looks like when you do this one setup. So again, I started with my other reactant, and I'm considering the cheese. This is the molar mass step because that is the molar mass of silver nitrate. You can go look up what all the masses are. Silver's 107, nitrogen's a 14, and oxygens are 16 times 3. So that's where that 169.87 comes from. And then here is our molar mass step, or sorry, mole to mole step. And again, it's 1 to 1 because this particular equation has coefficients of 1 all the way across. And when I do the math on that, I get 0.029 moles of AgCl potentially formed. So here's my two possible numbers of sandwiches. So I've got 0.043 is one possible, and then 0.029 is my second possible. So between these two, one of them's limited and one of them's excess. So we got to take a look at making that last decision now. I have two values. Which one's sort of the real value? Which one's the theoretical yield? And for that, we have to go with the smaller of the two. Oops, so I'm going to go to this one and start labeling this out. So here, I just gave myself some more room to work, sorry. So here is our smaller of the two, so that's got to be my theoretical yield. Again, this one up here is just sort of an imaginary number. It's theoretically, or not theoretically, imaginary, hypothetically speaking. If I had enough, I could make that, but this is our limited value, so this is the one I really want to focus on. Always look at that smaller number. So if that's my theoretical yield, that means that that has to be my limiting reactant. Silver nitrate is the limiting reactant. Remember, it has to be a reactant to be the limiting reactant. It has to come from the left side of our equation. And what about our sodium chloride? Well, this one up here, again, that's our one that's too much, so that's what we would call our excess reactant. So if I have problems where I ask you to identify which one's the limiting reactant, which one's the excess reactant, you always got to go back to these beginnings. This is not a limiting reactant. This is a product, and so it's the theoretical yield, and that's kind of one of the common mistakes that students make. Okay, so whenever you're trying to do these on your own, keep that grilled cheese example in your head. Whenever you're trying to decide, like, how many sandwiches could I make, you do it so fast you don't even realize you're doing it. But you consider each reactant separately and kind of figure out how much of the product you could get. And then you know that whatever the least amount of product is, the fewest sandwiches, that's the number of real sandwiches you can make. Because I guarantee if you went over to someone's house for a grilled cheese sandwich and they gave you 2 fried pieces of bread and said, here's your grilled cheese, you would be unhappy. So you want to make sure that you're going with that correct value, that least number. So here's our chemical terms that goes along with our vocabulary for this and our strategies. So number 1, make sure that you're always doing 2 stoichiometry problems, 1 for each reactant. Number 2, you have to go to the same product. In that last equation, we had 2 separate products, and I went to the same one each time, like a precipitate. So that's important that you always end up at the same product. The one that has the least amount of product is called the theoretical yield. Of our 2 answers, the theoretical yield is the correct answer. And then the reactant that made that is called the limiting reactant, and the other reactant is what we call the excess reactant. So there's your kind of 3 vocabulary term that goes along with our grilled cheese sandwich problems here. So here's an example problem for you to give a try to see if you can figure out how to make this one go. This is where you get a piece of scratch paper out and work it out, and I will do it here in a second. And we'll see if you are on the right track. So again, 2 stoichiometry problems, 1 for each reactant. You're going to get 2 possible answers. You go with the smaller answer, that's your theoretical yield, and then you can figure out which ones you're limiting in excess reactants. So, I guess I should put that away, right? So this is where you hit pause and you go get your periodic table and scratch it out, and I'm about to go do it here. You ready? Okay. So here's the worked out answer. So here's my first problem. I would consider here I'm starting with zinc because this is one of the ones that was given to me. And the question here asks about zinc chloride. So I'm going from zinc to zinc chloride. And again, with here I'm starting at zinc and my last score has to have zinc chloride in it because that's just what this particular problem asked about. I could have asked about hydrogen, but this one's asking about grams of zinc chloride. So I start with my zinc. My first step here is my molar mass step. I just found the mass of zinc on the periodic table since it's an element. And then the second one here is I'm going to use my mole to mole ratio. And my balanced equation is given up there. So I know that 1 mole of zinc is going to produce 1 mole of zinc chloride. And there's my mass. When I do the math out on there, it's 0.107 moles of zinc chloride could be produced from that much zinc. So now step number 2 is to do the other reactant, the HCl. So here's what this one looks like. Again, starting with 8 grams of HCl. Here is my molar mass step for hydrogen chloride or hydrochloric acid. And then in this one I've got a 2-to-1 ratio. And again, this is my mole to mole step. It's the balanced equation, and this is the coefficients. There's a 2 moles of HCl because there's a 2 up here, and there's 1 mole of zinc chloride because there's a 1 over here in front of it in that equation. So again, with this one you have to use the balanced chemical equation. That's my mole to mole step. So math it out, I get 0.110 moles of zinc chloride could be created here. So now I can look at these 2 answers and now I can make a decision which one is my theoretical yield. Again, with this one, always choose the lesser of the 2. So it's got to be that 0.107 is going to be my theoretical yield. And that means that reactant, zinc, has to be the limiting reactant that goes along with that. The other one has got to be my excess reactant. I had too much of it and it's sort of an imaginary value to it. So there you go, pretty much the basic stuff here. Last piece. Our answer here is in moles. These are both in moles. And the question here asked me for grams. There's 2 different ways you can do this. One would be to tack a molar mass step at the end of each problem, and that's fine. Or, in this case, since I have moles, I can just do one more little mini wonder fraction to convert from moles to grams. And so that's what I decided to do here. I took my theoretical yield, my 0.107 moles of zinc chloride, and then there's my molar mass step to convert from moles to grams, and there's my final actual answer right there. 14.6 grams with 3 sig figs would be the actual answer, theoretical yield of zinc chloride in grams. This one was the theoretical yield in moles, and this one is the theoretical yield in grams. Sorry, I hope you were done looking at that. Yeah, that dog was like me. You want that cheese? So here you go, kind of overviewing the entire thing. What did we actually do today to figure out the limiting reactant problems? Limiting reactants are our grilled cheese sandwich problems. So this is the kind where we know, you identify them by knowing amounts of 2 different reactants. That's the key to looking at this going, that's a limiting reactant problem. One of them will always run out first. That's a limiting reactant. You have to find it indirectly, but that's the limiting reactant, the one that runs out. It limits the amount of product. The other one will be left in leftovers. We'll have excess of it, so that one is called our excess reactant at the end. And we're usually less excited about the excess reactant than we tend to focus a lot about the limiting reactant. Our strategy when we're solving these problems, you always do 2 parallel Stoich problems where they kind of have the same format. Reactant number 1 to the product and reactant number 2 to the product. And when you set these up, you make sure you're doing 1 for each reactant. Always go to the same product. Typically, I'll try to give you a product to go to. But if I don't, you just have to go to a product. It doesn't matter which one it is. Just make sure to pick the same one each time. And then whatever your least amount of product is the theoretical yield. You can either calculate that in terms of moles and then potentially convert it to grams, or you can go all the way to grams in each one of your stoichiometry problems if you wish. And again, you can do that as a separate step, or you can do that within your 2 parallel Stoich problems, whichever one makes you happier, I guess. Makes sense to me. So there you go. I hope you enjoyed our particular lesson today on grilled cheese sandwiches. And I just want to say that any country where this object that you can see this glorious thing could be created, it's a good country, man. America. Have a good day.